Find the values of the numbers m and n that will make this equation true, given that m and n are positive numbers. So in maths, when we say to make something true, to make an equation true, it is true that 2 does equal 2. I hope you'd agree. If not, good luck. It is also true that 3 is greater than -5. Alright. If 3 is greater than x, what value must x be for this to be true? Could x be positive 4? Could x be 3? Could x be -100? Right? So it's up to us to determine this value to make this inequality true. In this problem, we're given an equation. Alright, we need to make this equation true, which means the left-hand side must be equal to the right-hand side. And our job specifically is to find the values of m and n. So notice on the left-hand side, we have brackets squared. So we could expand that out. And on the right-hand side, we have a quadratic. So let's expand the left-hand side. I'll just rewrite it first. 2x plus m all squared equals 4x squared plus nx plus 9. So let's expand the left-hand side. If it helps, just write out your bracket term twice so you don't miss expanding out the middle term like I always do. Alright, so we're just making it nice for us to tackle. So 2x times 2x, so we'll use our FOIL, is 2 times 2 is 4, x times x is x squared. Then we have 2x times positive m, which is positive 2mx. Then we have positive m times 2x, which is another 2mx. Notice I wrote these in the same order, so it's easy to tell that they're like terms. But if you wrote 2xm, it's the same thing. It's just a little bit harder to see that these are like terms. So keep to an order. Alphabetical order is best, but as long as you're consistent. And then m times m plus m squared. And all of that equals 4x squared plus nx plus 9. So with what I just said before, we can now group these like terms, right, just to simplify it. 4x squared, so we have 2 lots of mx plus 2 lots of mx gives us 4 lots of mx plus m squared equals everything on the right. Okay, now we can ask the question, all right, is the left-hand side, so left-hand side, is that equal to the right-hand side? If it is, then this equation is true. So let's have a look at each term. So we have 4x squared, 4x squared. Okay, they're identical. That's great. Now we have 4mx and then nx. Okay, they look a bit different. And then finally we have m squared and 9. M squared and 9. Okay, but our job is to pick the values of m and n to make these sides equal. So if we look at the pink term, the last term, for the left-hand side to have plus 9, what must m be? Right, in other words, m squared needs to equal 9. So m would be the square root of 9, which is plus or minus 3. All right, so again, just to summarize that, if we replaced m with 3, this pink term would be plus 3 squared, which is plus 9, which is the same as the right-hand side, making that part of the equation be true. but we have that middle blue term there. So let's move to that. So we want 4mx to be equal to nx. So I see x in both, so those are already equal, but now we need to make 4m equal to n. Now what did we say m was? Plus or minus 3. Actually, going back to the question, m is a positive number, so we can ignore the negative 3 in this case. So m is positive 3. So 4m times x is actually 12x, right? Replacing the m with 3. 4 times 3 gives us 12. Ooh, 12x equal to nx. So what must n be equal to for this sort of smaller equation to be true? So n must equal 12. So in summary, m would be equal to 3 and n would be equal to 12. So to recap this one, we had an equation and we were looking for two values, m and n, to make the equation true. And so what true means in maths is that the left-hand side is equal to the right-hand side. So we expanded the left-hand side and noticed they were pretty similar, right? They both had a 4x squared in it, but then we could pick the value of m as 3. So the last term, m squared, is equal to 9, which then let us pick the value for n, so that plus 4mx is equal to plus nx. And we had our two positive numbers, m and n.